All right, good morning. Doing this video here to go over the 5D notes for today and to get started. Um, I'm going to bounce around some of these things a little bit here just to make sure you guys all get the concepts and the definitions and stuff like that, and then we can try the practice problems on our own. I'm going to draw a few example problems up for y'all as well, in addition to these notes here. So let's get started. Okay, first thing I want to talk about is the geometric mean. Okay, if we're trying to find the geometric mean between two numbers, all you're going to do is you're going to multiply them, and then you're going to take the square root. Okay, so whenever you're trying to find the geometric mean between two numbers, you multiply them and you take the square root. Okay, so if I were to look at this last one here real quick, 4 and 16. Well, the geometric mean of 4 and 16, well, I'm going to do 4 times 16 and take the square root. Okay, so 4 times 16 is 64. So the geometric mean of 4 and 16 is 8. Okay, again, you just multiply the two numbers, take the square root, and that's how you get the geometric mean. And this is going to go into what we're going to talk about here with some of these similar right triangles. Okay, so this is what we're going to get at here. Okay, so there's some more geometric mean problems there that y'all can try on your own. All right, so next theorem here. All right, I know pre-AP classes talked about this a little bit. The altitude. Okay, altitude's another word for height. Okay, the altitude on a right triangle that's at the hypotenuse of a right triangle is going to form two triangles that are similar to each other, and they're going to be similar to the original triangle. Okay, and they're going to be similar by AA. Okay, angle. All right, I'm going to show you why right here on this picture, and so I'm going to just draw some angles in here. Okay, so if I'm looking at this big triangle, triangle BCA, it's a right triangle. Okay, so I have a 90-degree angle down here, and I have angle A and angle B. Now let's just say hypothetically angle A is 20 degrees there, making angle B have to be 70 degrees there. Okay, so we got this big orange right triangle here, triangle ABC. All right, Z is altitude. Okay, so that line segment Z is the altitude, and it goes from the hypotenuse up to our vertex C right there. Okay, that's what altitude does. It's a height at 90 degrees. And now it creates two additional triangles. So what I have is I have this green triangle here, DCA. That kind of looks like that. And I have this blue triangle, BCD, which kind of looks like this. Okay. Now we notice if we're looking at this green triangle right here, DCA, I still have this 20-degree angle down here at angle A. All right, I have a 90-degree angle where the altitude meets. Okay, and by rule of right triangles, this angle DCA down here has got to be 70 degrees. Okay, so I have my orange triangle. Okay, with a 70-degree angle and a 20-degree angle and a right angle here. I'm going to redraw this green triangle here that looks like this. So this green triangle has this angle, the 70-degree angle up there, which is the C. Has a right angle there, and it has a 20-degree angle down there, which is angle A. All right, and lastly, if we're looking at this little blue triangle, triangle BDC, okay? If we're looking at triangle BDC, all right, we notice that it has a 70-degree angle up top there, angle B. Okay, it's from the big triangle. It has a right angle down here at the altitude, and so that missing angle's got to be 20 degrees. So I have another triangle here, this little blue triangle, BDC, that has a 70-degree angle, a 90-degree angle, and a 20-degree angle. Okay, so I have this little blue triangle right here, where I also have a 70-degree angle, right angle, 20-degree angle. Okay, so what's going to happen is all these triangles are going to be similar to each other. Okay, all these little triangles are going to be similar to each other. Okay, now I want to look at there's a couple different rules that we can look at here, and I want to look at particularly the two small triangles. Okay, there's the blue triangle right there and the green triangle right there. Okay, in that blue triangle, the little leg is W and the larger leg is Z. Okay, in the green triangle right there, the little leg is Z. Okay, and the larger leg is X. Okay, so if I were to take this little blue triangle right there, little leg is W, larger leg is Z. Okay, little leg is W, larger leg is Z. Green triangle, little leg is Z, larger leg is X. Okay, morning. Um, so now we see that the legs are X and Z on ADC and CBD, the legs are W and Z. These two triangles are similar. What we could say is that W over Z, okay, W over Z is going to equal Z over X. Okay, W over Z is equal to Z over X. Okay, now if we were to solve this proportion, W over Z equals Z over X, okay, we would say that WX is equal to Z squared because we cross multiply. Okay, so if we have W over Z equals Z over X, we cross multiply, so we have WX is equal to Z squared. Okay, so Z, we're going to multiply W and X, and we're going to take the square root. Okay, so what's going to happen is Z is going to be the geometric mean of W and X. Okay, now what does that mean when we come to this geometric mean hypotenuse theorem right here? Okay, well, going back to this triangle here, Z was the altitude, right? Z was the altitude. Okay, now this altitude Z is going to cut my big hypotenuse into two pieces, W and X, right? It cut it into W and X. Well, we just saw that Z, which is the altitude, is going to be the geometric mean of W and X. Okay, so whenever we have an altitude of a right triangle drawn at 90 degrees from the hypotenuse, okay, the length of the altitude is going to be the geometric mean of the two segments. Okay, the length of the altitude is going to be the geometric mean of the two segments. Okay, again, that goes back to this thing here, W over Z equals Z over X. All right. So that's that for right now. We could try these two problems here. Okay. Again, W over Z equals Z over X. We just have to make sure that we know what our W and our X and our Z are. Okay, in these things right here. And so what we're gonna do here is we're just gonna be working on 3A here to find Z, which is the altitude, and we're gonna be working here to find the X, which is that thing right there. Okay, and we can sort of disregard, these other variables here for a minute. Okay, we're only really sort of working along the altitude right there. Okay. So if we were to look at one quick example, right here. So let's say we have a right triangle, okay, and we have our altitude. Okay, our altitude. I'll call it Z. All right. Now let's say we have this hypotenuse right here. It gets divided into two pieces. Let's say it gets divided into 4 and 9. Okay, real simple, 4 and 9. Okay, we know that we could set this up two different ways. Okay, we could say, well, 4 over z is equal to z over 9. Okay, and then what happens is when we cross multiply, we end up saying that, okay, z is a geometric mean of 4 and 9. So 4 times 9 is equal to z squared. Okay, 4 times 9 is 36 equals z squared. So z is going to equal 6. Okay, this thing is a geometric mean of this piece and that piece. All right, so that's the geometric mean hypotenuse theorem. When the hypotenuse is divided into two pieces, these two pieces, you take the geometric mean of those two pieces and you get the altitude. All right, so you could try 3A and 3B out there. All right, next, I want to talk about the geometric mean leg theorem right here. And take a minute to copy everything down if you need to copy all this stuff down. Pause the video if you need to. Go back if you need to. I'm going to clear the screen here and show you guys the geometric mean leg theorem right here. All right. So I'm going to redraw all these my three triangles right here. Okay. I'm going to call the W plus X. I'm just going to call that H for the whole hypotenuse. And you see I put a U and a Y in there as well. So I have my three similar triangles here. All right, and I'm going to redraw these up. So my big one, okay, I have U, Y, and H. Okay, and then my green triangle here, Z is my smaller leg, X is my larger leg, and Y is my hypotenuse. All right, and then in my smaller triangle here, we have W, which is my little leg. Z is my larger leg. And U is my hypotenuse. Okay? All right. So what we're going to look at here is we're going to look at these little triangles here. And we're going to be looking at the hypotenuses of these little triangles here. We're going to look at this hypotenuse U, okay, and how it works with my big orange triangle right there, okay? So if I were to make a proportion here with U, okay, what's going to happen here is that U is going to go with H, okay, because U is the hypotenuse of this little triangle. H is the hypotenuse of the orange triangle, okay? All right, and I'm going to work with two sides here, okay? So U with the H, okay, is going to go with W and U there, okay? So what's going to happen is going to be, you know, U over H is going to be W over U. Okay? So what's going to happen is if we're looking for u, okay, u, which is, we're going to multiply that, we're going to have u squared is equal to h times w, okay? So u squared is going to be h times w, okay? Then when we root that, u is going to be equal to the square root of h times w. All right. Now if we wanted to find the y, okay, now we're going to work with this triangle here. So in this triangle here, y goes with h. Okay, y goes with h as x goes with y. Okay, so in this triangle, we'll have y over the big hypotenuse is equal to x over y. And so we have y squared is equal to h times x. And so y is going to equal to the square root of hx. So y is going to be the square root of the hypotenuse times x there. All right. So what does that mean? Okay, what that means in plain simple English is that, okay, the leg in one of these little triangles is a geometric mean between the whole hypotenuse and the part of the hypotenuse that is closer to that leg. All right. So here's what this sort of looks like, guys, is that I have two legs in this big orange triangle right here. I have two legs in the big orange triangle. I got u and I got y. Okay. So if I'm looking for u, okay, what I'm going to work with, I'm going to work with my h, which is the whole hypotenuse, and then the part of the hypotenuse that's closest to u, which is w. Okay. And so what's going to happen is u, which is that leg, is going to be the geometric mean of the whole hypotenuse h and w, the part that's closest to it. Okay, we have that written up here. Okay, if we're looking for y, which is this leg down here, we're going to use the whole hypotenuse and the part that's closest to it, which is x. Okay, so y is going to be the geometric mean of h and x. Okay, and we sort of did these fractions over here already to sort of prove that. And so those kind of fractions sort of generate this rule a little bit right here. So again, the length of one leg of these triangles, and I'm talking about the big triangle right here. When I'm talking about the triangles, I'm talking about the big triangle, is going to be the geometric mean between the whole hypotenuse and the part of the hypotenuse closer to that leg. Okay. So, you know, a couple ways we could look at it. We could look at it as, okay, u over h is equal to w over u. And then we could look at y over h is equal to x over y. Remember, none of these have anything to do with the altitude. That's why we're not working with the z right here, okay? So the z and the z are kind of irrelevant for right now, okay, because these have nothing to do with altitudes. We're only looking at the legs, u and y, right there. And so that's how we'll sort of set those bad boys up. I would maybe use a separate sheet of paper to copy that stuff down. And we'll talk about the rest as we move along here, okay? And that'll be it. And y'all have a good day. Thank you.